My first step in this problem is to find the mass of the solvent. So in this, I have 100.0 milliliters of water. And then I'm going to multiply that times the density of water to get the mass of water, 1.09 grams divided by milliliters. So I have 100 milliliters, and I'm going to times that times 1.09. That gives me 1.09 grams of water, 109.0 grams of water. Now, this is just the water. This isn't the solution. So your second step is to find the mass of the solution. So I'm going to take 109.0 grams of water. I'm going to add the mass of calcium chloride, so 9.98 grams of CaCl2. And that's going to give me 118.98. And that's my grams of solution. So then my step 3 is just to plug into the formula at this point. So I'm going to take my 9.98 grams of CaCl2, and I'm going to divide it by the mass of the solution, which is 118.98. And I'm going to multiply that times 100 because this is a percent by mass. So 9.98 divided by, okay, and then times 100. Gives me 8.39. Again, 3 sig figs here, 4 sig figs here, so 3 sig figs. 8.39% CaCl2. Okay. Number 6 is just going backwards from that. So you're finding the mass of calcium chloride in a 5.7% solution. And then number 7, if 7.8 milligrams of lead is dissolved in 2 liters of water, what is the parts per million of the solution? Assume that the volume of the solution is equal to the volume of water and that the density of the solution is equal to 9.98 grams per milliliter. So again, here I've been given 7.8 milligrams of PB, of lead. And I've been given 2.00 liters of water. I have a density is equal to 0.998 grams per milliliter, and my unknown is parts per million. Okay, so first step in this is to convert your liters to grams. So I've got 2.00 liters. I need to convert that into milliliters first before I can use my density, because my density is in milliliters. So I got 1 liter is equal to 1,000 milliliters. And then that's going to be multiplied by my density, which is 0.998 grams per milliliter. So milliliters are canceling out, grams or liters are canceling out. And then I can calculate that. That gives me 1,966 grams of solution, because we're assuming that the volume of the solution is equal to the volume of water. So 1,998. So 1,998. My second step is going to convert this milligrams to grams. So 0.7, so 7.8 milligrams times, that's going to be divided by 1,000 milligrams per gram. So that's going to be 7.98 times 10 to the minus 3. Again, if you want to, you can just move the decimal place over 1, 2, 3 places. So your decimal point's there. You have 2 zeros in front. I just put it in scientific notation. Your last step is to plug into the formula. So 7.8 times 10 to the minus 3 divided by 1,998 grams. So this is grams, so grams are canceling out, and then that's times 10 to the 6th. It's going to be parts per million. Raised to the 6th. So this is 3.91, 3.9, so 2 sig figs, 3 sig figs, so 2 sig figs. 3.9 times parts per million lead. Okay. Again, number 8, you can do for extra credit, but that one is doing parts per billion instead of parts per million. Same type of concept there. All right, so this was learning objective 6. Solve problems using molarity, molality, and mass percent of solution. Again, all of these formulas are in the back of your periodic table. You can use all of these as conversion factors because that's essentially what they are: molarity, molality, and mass percent. Parts per million, parts per billion are all a conversion factor because we're putting two things over one other thing. You learned this back in Unit 1.